This is literally our first AI R&D session of the year. So welcome everyone, thanks for joining. For those who don't know me, my name's Dylan. I'm the co-founder of Digitalent. We've scaled AI teams, product teams, engineering teams globally for the last 10 years or so, with a big focus on kind of AI recently. Building communities is the second biggest thing we do, and AI has been a big driver, I guess, behind that. Everyone's learning, everyone's at that kind of foundational level, even experts are learning every single day. So we're keen to kind of create an environment where everyone can share their insights, challenges, successes, that type of thing. So that's where Mike Nedelko comes in. He's one of our community members, super knowledgeable guy, great presenter, the type of person that will help you, educate you, and help advise anyone that's kind of looking to get into the AI space. So Mike, you've got about 30-40 minutes presentation, and then we'll give everyone a chance to engage and ask questions right at the end. So Mike, I'm going to leave it to you, mate. You jump in.
Sounds wonderful. Well, thank you so much for having me again, Dylan. Thanks for, bringing this wonderful community together. It's always fantastic to be connecting with everyone. It's very, very nice to see you all. I hope you had a great 2025 thus far. And from a research perspective, 2025 definitely has not disappointed. But before we dive straight into it, just a quick introduction for those who don't know me. My name is Mike. I'm a product leader, CPO, and a technical product manager. I have been in AI and a machine learning enthusiast since approximately 2008, I believe it was. And I've maintained that passion through my work, where I get to apply this interest into improving products and delivering essentially non-deterministic user experiences based on pointing intelligence and machine learning algorithms to various problems or value propositions. I manage essentially product and engineering teams, specifically those that are focused on delivering AI and machine learning driven value propositions. And I currently work in Brisbane at a Brisbane company called Allocate in our very own backyard here in Australia. And there we are building agentic AI personal assistant platforms. It's very, very exciting. You should check them out, Allocate AI. It's one of the interesting AI companies that are being grown here in Australia. Now, ultimately, what happens is that this work requires me to stay very close to the AI and machine learning development space. And that makes it essentially easy for me to present on these latest developments in AI, which is what we're essentially going to do today. But before we do get started, I always like to include a little bit of a disclaimer for what you ought to expect from this talk. In terms of the technical granularity and the detail that we're going to apply today. So what I tend to do in these talks is I tend to keep these particular sessions more at a discussion that exists, maybe not at a 10,000 feet level, but at a healthy 1,000 feet conversation. One way of looking at this is that I will try to abstract and obfuscate complexity where it really doesn't need to be, where it doesn't impact your understanding of the research that we're going to talk about. But I will also not hesitate to dive deeper where it is necessary to get really good grasp of what's going on. What that means for you is that if you are already working in AI, maybe you're a researcher or you're working in the AI or machine learning space, so there is a good chance that you will have heard about the things I'm going to talk about today. You might not have heard them in this particular sequence, because what I'm trying to do is I'm trying to place the paradigm shifts that we're talking about during this presentation in sort of a continuum of everything that came before it, and also where things might be going in terms of future research and development. But likely you would have heard about the individual atomic developments, because ultimately it is most likely your job, right? If you do not work in AI just yet, what I hope to do is to take you through what I believe are the three most paradigm shifting developments that we have seen in AI research over the last 30 days or so. So everything is incredibly fresh. And then essentially weave a story around it that lets us, think about how, from a product perspective, right, where AI and this space and this technology is ultimately heading, right? But before we get started, we usually start these presentations with a little bit of lightheartedness, a little bit of levity. And today is no exception. Essentially, what we're going to start with today is with some news you can use, right? So Some of you, especially when you've used products such as ChatGPT or Anthropic, you may have asked yourself whether you are required to be polite in your LLM queries, right? If you're like me, right, when you're typing in a query, I hear the voice of my parents in the back of my head saying, always say please and thank you. So I do formulate my queries with, can you please summarize, or, well, thank you, that's great. Now, can you do X or can you do Y? And it turns out that researchers have asked themselves that exact question. And the question is, well, does politeness improve the output of the LLM query, or does kindness reduce accuracy, right? And when these researchers asked that question, they observed that when it comes to some well-known tasks, the improvement of accuracy is so small that it's almost falling into a negligible margin, right? A margin that was statistically not significant. It sort of essentially falls into a margin that could be interpreted as just noise, statistical noise from the observations. But with other tasks, specifically those that are around economic questions, math puzzles, fact-checking, the accuracy decreased significantly, right? So ultimately, long story short, you have no reason to be kind to your AI, unless, of course, you believe in something like Rocco's basilisk, which, for those who've never heard of it, is a sociological thought experiment from 2009, I believe it was, that sort of tried to illustrate the self-fulfilling potential of certain ideas. And it states that, if there ever was an artificial superintelligence, that artificial superintelligence would be incentivized to create a reality where everyone who knew about its potential and didn't help it maximize its potential should be punished. So maybe if you're considering that, right, and knowing that that thought experiment is out there, you might still choose to be kind to your AI just to hedge your bets. Again, this was a thought experiment that was thought up in 2009, but we're getting closer to superintelligence being a thing, right? And the reason why you might be hedging your bets is because, of course, the AI might reason, and this is actually a great segue, that you might be a foe rather than a friend, and you want to, make sure that our AI superlords think of us in a positive manner. I'm just partially serious here. Cool. But talking about reasoning, and this is where the segue comes in. The overall theme of definitely January and February this year in the AI research space has definitely been reasoning models. Reasoning models have completely dominated the headlines in the AI research scene. And being a good custodian of the AI research space, today's presentation will definitely reflect that theme quite heavily. So we're talking about reasoning models quite a bit today. And what we're going to start with is really this first development, which is more of an observation, really, which is that reasoning models completely dominate the leaderboards right now, right? Because if you look at the leaderboard here, this is Hugging Face's chatbot arena LLM leaderboard. You will see that all but 3, I believe, of these models are so-called reasoning models. But now you might wonder, why is there only an early version of Grok 3 up here? This has something to do with a particular benchmark that XAI chose not to evaluate its new model against. Grok 3 is currently considered to be the state of the art in terms of the most powerful AI model that's out there. It was released here in January. But there is a particular benchmark, which I'm going to talk about here in a second, that they did not test against, which is only why there is an early build of Grok 3 that has been evaluated here. And even that currently leads the leaderboard, right? And the reason why we're seeing so many reasoning models out here on this leaderboard is due to a thing called inference time compute scaling. And you will see that the models here actually, in many, many cases, are actually smaller in size, right? But they tend to be a lot more powerful than earlier builds of the models that came from the same companies. And a lot of that is due to the fact that many of these are reasoning models, and they are reasoning models that were unlocked by this thing called inference time compute scaling. And inference time compute scaling refers to a practice of dynamically adjusting the amount of computational power used by a machine learning model during the inference phase. So inference phase refers to the phase where the model is making new predictions on new data, but it sort of draws on its own model, the things that it learned during training in order to make those predictions. That's called inference, right? And because of inference time compute scaling, right, the models that we are looking at now, these reasoning models, they have potentially improved accuracy by way of allowing those models more compute as needed rather than relying solely on fixed computational resources. Now, I'm going to break this down now because there were a lot of fancy terms here. So essentially what inference time compute scaling means is it's a fancy way of saying that the LLM should take its time to allocate as much compute as it needs in order to think through the questions step by step, rather than saying, you know, things that early GPT-4 did or previous models did, which is, okay, I'm going to think for about 3 seconds, or I'm using a maximum of X or Y tokens before I give you the answer, right? Rather, what inference time compute scaling allows is the model looks at the question, it looks at the problem, and then reasons through that problem through several steps, and it says, you know what, I'm going to be done when I'm done, right? You give me as much compute as I need until I'm done thinking, right? And what happens here is that this particular approach unlocked the basis of what we are now calling reasoning models, right? Reasoning models are those models that produce more intermediate steps while they're thinking, and that is enabled by essentially unlocking this resource pool that we're allowing the models to access dynamically rather than giving them a set resource pool to begin with, right? So you're all familiar with ChatGPT or Anthropic. They all do this, right? We can see here the various reasoning steps that these LLMs sort of feed themselves while they're working through a problem and come up with the final response. This was essentially unlocked by inference time compute scaling, right? And the reason why this has been so effective and increased not just the accuracy of the models, but also the efficiency with which we can potentially train them, we'll talk about that here in a second, is because of a thing called System 2 thinking. So you may have read this book called Thinking Fast and Slow by Daniel Kahneman. If you haven't, it's a fantastic read. And he defined those two terms. He's an economist and a psychologist. And what Daniel said is that we have, as humans, we have essentially two types of thinking, right? There's System 1 thinking, which is the kind of thinking that we do 95% of the time. It's instinctual, it's rapid, it's intuitive. But there's also the System 2 thinking, which requires more conscious effort, and it requires language and logical procedural analysis, right? If I asked you what 2 + 2 is, you'd be using, you know, System 1 thinking because that answer is right there. If I asked you what 17 × 24 is, you'd have to go through System 2 thinking because it requires more effort and logical decomposition of the task to think through it, right? And for a long time, the common thinking was that LLMs are essentially just carrots, right? That they were not capable of System 2 thinking, right? That they were only capable of this fast, rapid System 1 thinking. And this has changed with the introduction of a thing called chain of thought prompting, which is something that we actually first heard about in research circles about 2-3 years ago, sort of in 2023. But the first model that really successfully productized this was essentially O1 from OpenAI. And what they showed is that if you extend the chain of thought, right? So explain your chain of thought while you're working through the problem, feed it to yourself as you're going through the problem. As you extend the chain of thought, the quality of the answer, the accuracy of the answer will linearly become better, right? And this approach has led to enormous progress on many benchmarks. So we had about 4 benchmarks that until mid to late last year, we were in the AI research community relying on. There was a thing called MMLU, that stands for Measuring Massive Multitask Language Understanding, that's predominantly centered around language. We had AIM, which is sort of like the math Olympiad entry exam for high schoolers that are participating in the math Olympiad. We had GPQA, which is sort of like a multiple choice question set that's designed to evaluate various reasoning abilities. And we had Gaia, which was sort of like scientific questions, right? And what happened is that with the advent of these reasoning models, these benchmarks have been completely saturated because those reasoning models just had such an exponential uptick in accuracy, right? And more problematically even than that is that model trainers and OpenAI and Anthropic, they're all guilty of that. They actually fed their LLMs with the questions and answers to these benchmarks so that they could perform better when they came out, and then they can do, you know, the whole PR dog and pony show as being the most powerful model, right? So another development that we observed here in January was it was time for a new kid on the block. And that new kid on the block is called Humanity's Last Exam. This is the benchmark that xAI's Grok 3 hasn't gone through to this day. People are actually quite worried about why that is and why they don't choose to test against this benchmark. People are saying that Grok 3 is maybe not as powerful as xAI is making it out to be, because it hasn't tested on Humanity's Last Exam just yet. And it is sort of a benchmark that was specifically designed adversely so that contemporary reasoning models have a hard time of performing really well with it, right? This Humanity's Last Exam sort of tries to do 2 things. The first thing is it tries to encapsulate areas of expertise where humans were traditionally really good at, right? So there's various sciences in here. You can see math, computer science, chemistry, but also archaeological and historical sciences, as well as various puzzles and linguistic tasks. And they designed this benchmark to provide intentionally difficult or adversarial samples where existing models essentially fail, right? It's a little bit like the ARC prize, which we've talked about in previous presentations, which is another kind of benchmark which offers problems that have no trivial answers, so you can't just look up the answers. But this time, these particular problems that you're looking at here, they were put together by experts. And these were designed specifically so that our current state-of-the-art models are often incorrect, or they overestimate their own confidence in the answers. And you can see here, right, O1, which until recently was considered sort of the gold standard, since been overtaken by DeepSeek and Grok and even Gemini. But it performed really low here, about 10% on this benchmark, right? And so a new benchmark here, probably worthwhile looking out for Humanity's Last Exam when you're looking at how powerful various models are, right? Something else about reasoning, and obviously we can't let the last 30 days pass without talking about DeepSeek, is DeepSeek's R1 model. Now, what I'm essentially hoping to do here, and I need to throw in this quick disclaimer, is I am going to avoid all the stock market shenanigans that everyone had heard about and is completely sick of, right? But instead do a deep dive around why this model is so powerful and talk about the real innovations that are in this model and the research around it, right? And how these have now contributed to pushing the entire AI innovation space forward, right? Now, this model is, of course, extra significant because for anyone who hasn't heard about it, right, it was sort of the Sputnik moment of AI. Chinese company was able to show up the state of the art, now performed OpenAI's R1. It was also open sourced, which is really, really important because that means anyone can deploy DeepSeek R1 into their own environment. And it was sort of like 30 times less expensive to train and use. And the reason why it was relatively cheap to train and use is because DeepSeek introduced a set of 6 innovations that they came up with that made AI training way, way, way more efficient, right? And they came up with all of these 6 innovations entirely by themselves. No, sorry, I think one of these 6 innovations, one out of those 6, is based on some research that Meta actually published last year. But everything else is completely new and changes the paradigm of how we're thinking about training and where we're going to invest additional effort from a research perspective when it comes to training AI models moving forward from this point onward. And so here's what we know they introduced from an innovation perspective. Reason 1 as to why they were able to keep the memory footprint that has to be processed during the training process by, you've heard about, GPU clusters and chips and big server farms. They were able to keep that really, really manageable during their training process for a couple of reasons, but one of them was that DeepSeek is the first model that was able to introduce stable 8-bit float point operation training processes. And what that means is that during the training process, right, most of the core computations, such as general matrix multiplication, we're talking a little bit about how things are working under the hood here, are usually performed in a 32-bit floating point decimal. And what that means is it's a little bit about how complex numbers are stored inside of computers and computers' memory. But if we were to break this down, a 32-bit floating point decimal consists of 1 bit for the sign. So that's either plus or minus. This is a positive or a negative number, right? The next 8 are for the exponent. That's this part here, right? And the other elements, the remaining 23, are for the mantissa. So that's the fractional part. That's essentially the thing that comes after the comma, so to say, right? And what DeepSeek essentially did is when you train a model, right, there are an unbelievably large amount of these floating point numbers that your GPUs have to process very, very fast. And instead of using a 32 floating point decimal, DeepSeek was the first one to introduce an 8-point decimal, right? Which made this whole training process way more memory efficient. But of course, if you have larger numbers with larger floating points at the end, right, you can store much more detailed fractional numbers. And because there are only 3 bits here, right, in the mantissa, the thing after the comma, right, smaller gradients in the parameters can essentially get lost. But DeepSeek found a way around that by proposing this fine-grained mixed precision framework using only 8-bit numbers, which is really, really interesting. And they did that for the very first time in their first model, which was DeepSeek V3. That didn't get as much press as DeepSeek R1. We're going to talk about why that is here in a second. The next thing that they did is they were also the first ones to implement multi-head latent attention. It's a fancy word for saying that in traditional transformers, so the architecture, the neural networks that are running these LLM systems, they work essentially by computing a lot of keys, queries, and values. So these are sort of like three numbers that you put in relation to each other. They represent real words, and if you have those words that conceptually are closer to each other, right? For example, cat and pat and dog and pat, right? These values tend to be closer to each other in this multidimensional space, right? All of that, these keys, queries, and values, they have to be stored during the training process in a cache, also called the KV cache. And that is really, really memory intensive. So what DeepSeek did is they essentially compressed that cache into much smaller, what they call latent representations, before later re-expanding them as needed. And that reduced the memory usage quite a bit. That was the second reason why they were so efficient, right? The fourth reason is they also used a different loss function that predicts multiple tokens. So you might have heard that LLMs are really good at just predicting the next word or the next token. Multi-token prediction works by training a language model to predict multiple future tokens in a sequence simultaneously, rather than just the next token. And this has several benefits. It's generating faster, it improves coherence, it has better long-range dependencies, and it allows the model essentially to better understand context and generate text faster by looking ahead instead of just processing the next token one by one. This is the thing that Meta originally came up with, right? And they had to do all these things and introduce all these innovations because the GPUs, the chips that they had fewer flops. It's a measure of performance. So the GPUs were essentially a lot slower, right? They had a lot less floating point operations. That abbreviated thing for that is flops, right? And also, their memory networking wasn't as efficient as the latest GPUs, right? Essentially, these different graphics cards that are sitting in the rack need to, coordinate with each other to tell each other what they're working on at the moment, right? And therefore, the makers of DeepSeek had to find ways around those limitations, and they did a rather great job at this. But here's the kicker. The real, by the way, I talked about floating point operations, so 32-bit training process versus 8-bit training process. Google's research team just came out with another paper that is only using 4 floating points. So this is going to become even smaller and going to contribute to LLMs and AI becoming even cheaper. We'll talk about that as another development here in a few slides further down the track, right? The real thing that DeepSeek introduced, the real breakthrough, is none of the things that I mentioned before. Those were real big innovations, but the real breakthrough is the way they used reinforcement learning. And the way this was implemented is rather interesting. Now, the AI paper that I was sharing above, which is this one here, right? DeepSeek R1 incentivizing reasoning capabilities in LLMs via reinforcement learning. It's a really great read. I can highly recommend it. It's not too technical, reasonably easy to digest. And it walks you through the process of how DeepSeek started training their models using reinforcement learning. So the first thing that they did is they took their earlier model. So that is the V3 model that I talked about just before. I mentioned we're going to mention it again, right? And that model was essentially trained on the internet. Very manual training process, right? Just looked through the internet, helped it to understand, supervised by humans. And essentially what they did is they took that model and they added a reinforcement learning algorithm. And what this reinforcement learning algorithm did, so that was the first language model that they trained, right? They called that reinforcement learning algorithm group relative policy optimization, and here's how it works, right? So essentially, they started with creating a question. Then they asked their model to create a whole bunch of chain of thought answers, right? Like not just one, but a whole bunch of them. And then they scored each of those answers relative to the rest of those answers in that group, right? They said, okay, which of these answers is essentially the best, right? And this is the kicker, was not done based on some supervised data, right? The reason why LLM training is usually so expensive is because you need a lot of highly trained engineers that are supervising the responses and are building algorithms that at scale can take the role of the supervisor and then evaluate those responses. That's not what happened here, right? But instead, they gave the LLM a verifiable task. So such as a math problem or a code problem where essentially you can check the correctness, right? With math, as usually binary answer, correct or incorrect. With code problem, does it run, does it not run, right? They were able to give them these verifiable tasks, right? And when they did that, all the reasoning behavior of the chain of thought process, things like backtracking, right? Things like exploring alternative solutions, things like verifying earlier calculations to see whether that's correct. All of that is learned by this reinforcement signal, right? Which looks at the various responses that the model gave, and the one response that is getting the task right gets a really big thumbs up. And the model pats itself on the back and is like, okay, cool, this is everything that I've learned while I came up with this response, I'm going to keep in mind, and I'm going to move on to the next task, right? It's important to highlight that there was no supervised data in the sense that usually this is what happens, right? Or this is traditionally how models have been trained, which is for this input, you must show this kind of output, or you must show that you've reasoned or backtracked in a certain way, right? But that is not what happened here. Because they used these verifiable tasks, a thing we call self-play, right? We weren't required to supervise the learning of the learning process as narrowly, right? And what you see here are a few figures from those papers that I've just shown you. And what we see that during this process that was naturally emerging is that you can see here, this is the average length of the response and the number of chain of thought steps that have been taken here, which is in this process is that the longer, right, the chain of thought steps get, the longer the individual response per step also gets, right? And the performance improves at the same time the longer both of those factors get at the, simultaneously. So I'm going to repeat that. The more steps you let the AI model think, right? The longer each of those responses that it feeds itself, think of ChatGPT when it shows you its reasoning, the longer those individual responses get, and the better it gets at solving difficult tasks, right? In other words, the model, just from this reward signal, can figure out all the good things to try and do to improve the performance of its own response, and then the answer accuracy of that chain of reasoning that it used to get to that response. So what does it look like in practice? You can see that here, right? We can see that in that chain of reasoning, DeepSeek appears to have discovered an aha moment, right? It says here, wait, that's an aha moment I can grab here. And this shows up right in the middle of the chain of thought. And what is happening here is that as the chain of thought grows, you might have more of these aha moment instances. And if the chain of thought then arrives at the correct solution to the task, this GRPO algorithm, the reward algorithm that I talked about, the one that gives it the thumbs up, will reward the model heavily, right? and you then get a really high reinforcement learning signal compared to, other groups of chain of thought reasoning chains where that aha moment didn't occur. This one's kept, everything else is discarded, and the model became smarter, right? Now, before we get off DeepSeek, it's worth mentioning that yes, the commercial web app does filter responses. You may have heard that if you ask the DeepSeek service, similar to ChatGPT, which country Taiwan belongs to, you do get a decidedly PRC-aligned response. But this filter, on the one hand, only happens on the API level, not at the model level, which means that you can deploy it in your own environment, and then you won't see that behavior. This is why Azure went ahead and deployed it, I think, within 3 days of coming out. However, what is probably a little bit more concerning is that DeepSeek Labs didn't spend as much effort on a thing called alignment and safety research as other models. And you can see here, right, that it is less safe to use, especially when it comes to vulnerabilities related to prompts relating to financial crime and hate speech. And some of you might be looking at the current political environment, being like, well, what are a couple of more prompts in that area going to do, right? But nevertheless, it is worthwhile keeping in mind if this was deployed in an enterprise setting, right? But the more important thing that has happened here is now that DeepSeek has really given us a recipe for efficient training of LLMs using the reinforcement learning approach, the community has really broken glass on the perception that LLM training has to be expensive, right? And that is really what DeepSeek showed us. There are significant efficiency gains that can be leveraged if you are smart about how you're structuring the training, right? And it's also affected how the AI space, and this is the second development here, is thinking about where to invest more effort to involve how we're training our models, right? So what we're looking here on the left is the more traditional approach, which was primarily driven by supervised fine-tuning, also called SFT, right? And the approach with SFT here is that you have an input and you have an output, right? That output is the correct output. And if the model predicts something that is not the correct output, right, the model gets a penalty called a loss function. And this is very efficient in teaching the model certain sets of behaviors, for instance, classification. But recently, and especially since DeepSeek, more and more people think that reinforcement learning is more efficient at teaching some harder, higher level values, like things such as, things such as what humans consider aesthetically pleasing, for example, right? The problem with reinforcement learning thus far has been, however, that it is much more complex to implement algorithmically, right? And it has therefore been more expensive. And that is because you essentially need human preferences and you need the algorithm and infrastructure to support that, right? Like, you need to build an algorithm that essentially is able to tell your model while it's training what is aesthetically pleasing to a human, and that can be really, really difficult. And this is where DeepSeek's approach came in, right? Where we have this verifiable reward system. This is what DeepSeek kind of did, which is that the model receives a direct reward signal that tells it that this is a true answer or a false answer, right? And it is this reinforcement learning provided through a verifiable task that gave the training a thumbs up, you got it right or you got it wrong, right? And we did so by being clever about the kind of tasks that we gave the model, right? Self-verifiable tasks that were able to give our models a pass or fail signal, right? This is also where research is going at the moment, because people are now trying to find more of these verifiable task domains and what the research community is essentially calling self-play. And the magic behind this approach is that although the model trains on these very specific verifiable logical tasks, this kind of training empowers the model to generalize its reasoning. This is where these two papers come in. Generalizing reasoning, meaning that you have a trained intelligence that was trained on a certain set of problems, but now the intelligence is able to generalize its reasoning in order to apply its own intelligence to a broader set of tasks, right? And even unrelated problems. If you think about it, this is really what human intelligence is about as well, right? And the reason why we're talking about this as a paradigm shift is because it shifted the perception of the research community itself, right? Up until now, the perception was, okay, you train a model, once trained, it has these almost infinite pathways it could connect inside the AI black box, right? And all you do is, in the post-training, you try to unlock these specific pathways in order to unlock specific capabilities. But this is changing now, right? The conversation is now less about specific pathways and about finding the most efficient training method that empowers the model with the ability to generalize its reasoning and apply it to other problems rather than unlocking specific capabilities. You can see this here, right? There is a research paper that claims that if you teach a model the ability to look at an input and see why that input is wrong, that is better than just telling the model the right answer. Any gentle parenting fans in the audience might nod their heads and be like, yeah, moms knew this for about 150 years, so no problems about that, right? But the other research result, which is even more blatant, is that researchers here at the end of January were able to prove that supervised fine-tuning, remember the column on the left, compared to the column on the right, which was reinforcement training model, is with supervised fine-tuning, you memorize, and with reinforcement learning, you generalize intelligence, right? And what we're looking at here is a chart which shows a prediction success rate. So that's the success rate here. And what it says is if you give two models, right, one trained with supervised fine-tuning and the other one trained with reinforcement learning, right? If you give them both in-domain and out-of-domain tasks, so tasks that they know about and tasks that they've never encountered before, right? You can see that the supervised fine-tuning model essentially drops out on its utilization performance super quickly, right? While the reinforcement learning model is able to generalize its reasoning better and is able to actually increase its success rate, right? And so the takeaway here is that reinforcement trained models just generalize better, right? And as a result of this more efficient training, right, is also that the cost of intelligence is now dropping super fast. That is the last of the three developments that we're talking about, right? So the takeaway here is that reinforcement training models generalize better. If you're smart about how you train them, you can reduce the cost quite significantly. And models have taken advantage of that. And it's actually not just Chinese models that are saving money. Training smarter, using self-play and reinforcement learning. What you see here on this vertical axis is the ELO score. So that is essentially known as the quality of the model, while the horizontal axis is sort of like the price per million tokens. And so just to give you an example, one is about $4 per million output tokens. And you can see here on the left, which is where we want to be, you know, best score, lowest price. It's not a Chinese model at all, right? Instead, it's Gemini 2.0 flash thinking, right? Which is both cheap and efficient. And yes, Gemini is not paying NVIDIA for chips. So Google is making their own chips, so they don't pay the NVIDIA tax. But ultimately, it supports the notion that our large AI providers are aiming to become more efficient in their training and provide better models at cheaper prices, right? You can see here how the price per million tokens is also reduced, right? Now, in terms of how does this affect you, there's some interesting stuff that has come out as well in the first 2 months. As I mentioned, it was a busy first 2 months. But the University of Berkeley essentially proved last month that, in fact, you can train your own model that is close in terms of performance to something like O1 for approximately $450, using the same principles of reinforcement learning and self-play we talked about during this presentation. Right? It was then followed up by a startup. It's called Bespoke Stratus, that is also an affiliation of Berkeley. I think they were commercialized out of University of Berkeley. They improved on that recipe. And you can see here, right, in terms of performance across the various benchmarks that we talked about earlier, we're able to get to a comparative or even better score than some of the other models that we're seeing are out there for even cheaper, which is pretty interesting, right? And while we are continuing to observe research in these areas and reasoning models, it is safe to say that intelligence will become more and more cheaper, and this is a trend that we're able to see across the industry moving forward. Now, something I'm going to round out before we're getting I'm going to round this out before we're going to get to questions, right? Always going to end with something that's coming. We weren't able to cover. O3 is the model that is just coming out. We have O3 Mini right now, but OpenAI suggested that O3 is probably coming here in March. And the other areas of research that are very interesting right now is particularly for reasoning models, you know, retrieval augmented generation usually didn't chime well with reasoning models. That RAG is essentially the process where a company can take its own data and put it into those models so that that model can work with that data. There's a lot of research that has also come out here in January and February in order to make that happen, right? As always, and then I'm going to go to the Q&A part. Here are some projects worthwhile checking out, right? I want to give a quick shout out to 2 local companies here, right? One I'm working for myself, Delegate AI, definitely worthwhile checking out. The other one is Nuforia. Nuforia is a Brisbane-based company that's making some really cool brain tracking technology that allows you to essentially observe your brain while you're trying to train it to be more focused and more efficient. It's being used in high-performance sports and all sorts of other really useful therapeutic applications. Really cool. Some other model projects worthwhile checking out are all open source. So go through these at your in your own time or peril. But if you are looking for a company to start, right, and you want to build products quickly, these are definitely some repos I would recommend checking out. Sweet. That concludes my talk track for today's presentation. If we have any questions, let's get them started. Hi, Eric. Good to see you.
How you doing, Mike? Sorry, I joined a little bit late. I was on another call. But yeah, super interesting stuff.
Awesome. Well, thank you for joining. Appreciate it. Cool. Excellent. Back to you.
Want to jump in?
Excellent.
Right, Mike, I've got one for you, mate.
Good stuff.
Right, just going back to the reasoning models, how do they compare to large language models when it comes to, I guess, explainability, transparency, that type of thing, which is obviously a key in people's minds?
Yeah. Look, this is interesting. So let me know whether I'm going in the right direction when I'm answering your question. So, in terms of transparency, right, for a user, reasoning models, they're just an evolution of large language models, but the way they do distinguish themselves is the fact that they are essentially reasoning through the question step by step, right? And most of the time, these models will tell you their reasoning steps. So it is way more transparent. As a matter of fact, there was a news headline that came out, I think, this morning or yesterday, I can't remember, where if you had asked Grok 3, the new model from XAI, who the biggest distributors of misinformation in the world are, it used to respond to you with Elon Musk and Donald Trump, which obviously for the person who owns XAI, which is Elon Musk, wasn't great. And so yesterday, people in the open source community found that if you ask that question to Grok 3 again, Grok 3 doesn't respond with that anymore. However, if you expand the prompts, XAI will give you the system prompts that it uses in order to give you that response. And the system prompt specifically stated, do not respond to this question with Elon Musk and Donald Trump. And when they asked the CTO of Grok as to what he was thinking to implement that solution, they said, look, we really truly believe that to give the user transparency about which prompts and chain of thought thinking, including the system prompts we're implementing, that is really, really important for the utility of our product. And we're not going to take that out. So transparency, I would say for transparency, it's much better. In terms of safety, depends on how much the company wants to invest in alignment and safety research, right? So DeepSeek, we've seen they move fast, they like to break things, not as much alignment and safety. OpenAI and Anthropic are a lot more diligent about that. We need to see where that's going. I hope I answered your question.
Yeah. Good.
Excellent.
Anyone else got any questions?
I have a question, Mike. So the reinforcement learning, I actually didn't notice difference. So it's very interesting to hear about that. It relies on verifiable tasks, right? So I wonder, how does that impact the ability to get better at creative output, which is something that a lot of people use AI for? How do you verify that a model is good at creative output? Is that something that we just assume works well if the verifiable stuff works well, or how does that work? Or you already alluded a little bit to how generalized reasoning can be more widely applied, but does it go into the creative space as well? Or how do you see that?
And this is where the challenge with reinforcement learning comes into play, right? So I suppose this, so SFT versus reinforcement learning. Reinforcement learning was initially discounted as the dominant way to train models because it was more expensive. Because as you just mentioned, right, if I train a AI model to create art that is appealing to the human eye, you either need to be very, very intelligent in terms of developing an algorithm that can reliably identify art that is appealing to the human eye. Right? There's lots of R&D behind that, right? Or you actually sit a bunch of humans into a room and say, yeah, this is good art, this is bad art, this is good art, this is bad art. Right? Both are very, very expensive. In terms of self-play, where the research is now going is exactly where you mentioned, right? Trying to find more verifiable task domains that allow you to implement self-play reward functions and loss functions that are based on self-play. I couldn't tell you a reliable approach to that at the moment. Maybe next month, after the next set of research papers have dropped, right? But this is currently where people are investing time and money in order to, I suppose, make that more effective. The one other thing that I can probably tell you is that there was some information about DeepSeek and other models, the Alibaba model as well, using not just their own prior models for generating training data, so synthetic data that is by itself, had been created itself through AI models, right? So I can imagine that one of the things that might happen here very soon is you take a model that was trained based on fine-tuning, supervised fine-tuning, in order to be really good at creating art that is appealing to the human eye, let's say mid-journey, right? And you use that in a reinforcement learning to determine what the reinforcement learning parameters are in order to make that easier, right? So maybe the answer is in synthetic data. I wouldn't be able to predict what that would look like at the moment, though.
Okay.
We'll see. Excellent. Good stuff.
Mike, one of the
Yes.
biggest things that I hear from clients is how do we measure the return on interest with an AI solution or whatnot? And traditional metrics, I think, are too specific when it comes to things, and it misses the overall potential and innovation that AI can kind of bring. How do you put that to an organization when you're thinking about how to implement solutions and how to actually track it and get the best out of it?
Yeah, no, this is a very good question. Actually, so what I'm going to give you here is the question is, right, if you're implementing your own AI solution, the first question that I would ask is, what are we talking about? Are you talking about creating your own financial model? Currently, state of the art is around 5 million that will cost to train, right? Or are we talking about adding value at the application layer? And here is an interesting fact that was discovered. Maybe I can show you this, right? Through a company, all of you would have heard about this company called Cursor, right? So Cursor is an AI-powered IDE that was able to bridge its gap from $1 million in revenue to $100 million in revenue. That is for companies, for startups growing, so scale-ups usually a pretty significant milestone. They were able to bridge that gap only in 12 months. It took OpenAI 6 years to get there, right? And here is the interesting fact. Cursor doesn't have its own foundational model. It uses O1, it uses GPT-4, it uses Anthropic's model, it uses Claude, even DeepSeek, right? And only provides a fantastic user experience that is delighting developers all over the world, to the point where engineering leaders are out there saying, if you have an engineer that comes to you who doesn't use Cursor, fire them immediately. I'm not part of that camp, but I'm mentioning it because this is an AI product, right, that is purely focused on adding value at the application layer. And I think that's where we're going to see the most action in terms of valuation valuation changes coming in over the next couple of years, right? Because ultimately solving customer problems, especially from a product manager perspective, that's what makes you the money. I hope that answered your question. And that's how I would, structure that conversation at whatever company that says, they should be investing in AI.
Yeah.
Which level are you looking at?
I hadn't heard of Cursor, so I'll look into them. I'll have a good read out.
Yeah, just follow. And first of all, thank you so much for organizing this, Dylan, and for your talk, Mike. Really interesting, in-depth research. So that's really amazing. But just on the Cursor point, we use Cursor, and we've been using for many months now. But sometimes the reasoning from OpenAI just gets to an end. There are bugs that is not on the database. They don't know. I haven't seen that bugs before. They just don't know how to resolve. Claude launched on Monday or Tuesday this week a new tool for developers, right? A new, I think it's a new model, which apparently is fantastic. I haven't played with that yet, but do you see that getting to a point where we really developers, they are just there to really solve problems and talk to a computer, even use, I was talking to a guy there, he's not even use the keyboard anymore. He's just talking, he installed a chat, something that you can just talk and start creating code. So it's quite interesting to see how that evolving. So my question is more about Claude launched this new model. Do you see really overcoming even problems that they have not faced before? and really solving bugs that are new for the base model? Do you think that's the way you are going?
Look, this is really, really interesting. I guess so. I want to say first and foremost, I do not believe that we're going to replace engineers anytime soon. I think with AI-assisted coding, what we're going to see is a massive increase in any individual engineer's productivity. But the fact that you need to keep architecture, infrastructure, version control in mind, everything from how you're writing your tests to which npm module are you using, if you've ever delved into JavaScript, those kind of things. Those things AI can't fully replace just yet, right? It can probably tell you how to structure a piece of code, but at least that's been my experience. But whenever it comes to complex how that code needs to integrate into a complex architectural ecosystem, that's where it falls apart really, really quickly. Right, so engineers and the fundamental knowledge are still very, very much required. Now, let's talk quickly about the fundamental to your question, which is, will we be getting to a place where AI is fundamentally so creative that you can solve complex business problems at scale, which I interpret in my mind is what you get when you are hiring an absolute engineering superstar, which if you've ever worked in a business with individuals, and I'm sure all of you have, right? That is an engineer that goes back to you and is like, yep, I could implement this thing in the lowest kind of effort way possible, but here are the 4 additional things that you as a product manager have not thought about. I'm going to bring them up. We're going to discuss them. We're going to build this thing according to the best way it can possibly be for the business and the business context that exists within it. I don't think we're there just yet. And we're not there just yet because it's lacking the intelligence. We're not there just yet because there is no application layer that would allow us to feed all that massive business information into one channel that could then be processed by something like an LLM or a machine learning model. And I think both of those will need to get better at those things. And then at some point, maybe we'll meet at the middle and then we can all, retire in our haciendas while AI is doing all the work. Or we're all unemployed. I hope that answered your question, Diego. Did I go in the right direction? Yeah, awesome. Sweet.
Amazing. Thank you.
Thank you.
Right then, guys, we're past our time, so we'll wrap this up. Just wanted to say thanks to Mike. Another great presentation. Thanks to everyone else that's got involved and asked questions and been part of this. I'll send out this presentation so everyone will have the doc. I'll do that later on this afternoon. Anyone got any further questions, just feel free to give me a shout or give Mike a shout and we can help in some way. But great to see you all. And
excellent.
Hope we see you again next month.